Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Smarif. I will be explaining about our Verilog code part 1 along with Anis Anani. So basically, as for this one, this code is based on our 6-bit by 6-bit logic diagram. So this code is called assignment, and our input is A and B, while our output is P. Our wire is labeled as W, which is from W1 until W84. So basically from this, for our AND gate, for every AND gate, they will have one output and two input, which is the input is as for N1, the input is A and B, A0 and B0, while the output is P0. For this second AND gate, N2, the output is W1, A1, the input is A1 and B0, while the output is W1. So for the AND gate, they will follow this same process. So for the half adder, which is we just call it M4. So the output is P1, W3, the P1 and W3, while the input is W1 and W2, as you can see from this one. So for the half adder N4, the output is, as you can see here, is P1 and W3, while the input is W1 and W2. So as for the full adder N7, it follow N7, FA N7, which is basically so the full, as for this full adder, which is this one, FA, the input is W3, W4 and W5, while the output is W6 and W7. So for this is our full coding from start to finish for every AND gate and every half adder and full adder block. For the full adder module coding, or we call this one module, or we call this one FA, they have the input A, B and C in, while the output is sum and C out, and they have 4 wire in this one, which is labeled as N1, N2, N3 and N4. So they have 6 gate, and we need to code all 6 gate in the all the 6 gate in the full adder. So XOR, and for this XOR, they have the output is N1, while the input is A and B. For this one, the output is sum, the input is N1 and C in. So and for this AND gate, the output is N2, while the input is A and B. While this one, the output is N3, while the input is B and C in. And for this one, the output is N4, the input is A and C in. As for the OR gate, the OR logic gate, the output is C out, while the input is N2, N3 and N4. So that's the end of the full adder module. Anis Anani will continue with the presentation.
Assalamualaikum. My name is Anis Anani. I will present about half adder. For the module half adder, the input is A and B, and for the output is sum S and C out C. At the ZXO, the input is A B, and the output is sum. For the AND, the input is also A B, and the output is C out. From the input B and A, we will get the output 1 0 0 0 0 0 0 1 1 1 1 0. And that's all from me. Thank you.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Syahmin Kamal bin Kamal, and I will present for part 2. Okay, the question for part 2 is, we have to design, simulate and verify a synchronous digital system that detect and recognize student ID as password that can be used to generate an output signal. The student ID is entered to the system sequentially and synchronized to the master clock for proper operation of the system. The system is expected to generate an output logic high for 3 clock cycles in the ID sequence if the ID sequence is detected correctly. The system will then return to the wait state where it will wait for a new sequence to be entered by the user. So we have to use any of the student ID in our group member for this design. Here is our module for question 2. So we have the input of X, clock and reset, and an output of Y, which is we declare in the global equal to 0. So the rec to 0 is current state and next state. We have to set a parameter for the system, which is the case. So the parameter that we use is S0, S1, S2, S3, S4, S5 and S6, and every of it is a 3-bit data. So we start with our case function, always at current state or X, and begin the case current state. So for the first state which is S0, we start with begin. Y is equal to 0. If X is equal to 1, the next state will go to the S1. Else, which is 0, next state will go to current state back. So it will stay at S0, and we end the state. For the next state, which is S1, we begin and we will give an output of Y equal to 0, and then if X equal to 1, which means it's high, the next state will go to the S2. If the input is equal to 0, which is else, the next state will go to the current state, which is the S1, and we end the case. For S3, we start with begin, and it will release an output of Y equal to 0, and if X equal to 0, which it will become high, which is next state equal to S3, and else that state equal to S0. So when the input detected is 0, it will go to the S3. So for the S3 case, it will output Y equal to 0, and if X is equal to 1, it will go to the next state, which is S4. And if the output is high, which equal to 1, the next state will stay at S3, and we end the S3. So from this system, it is designed to detect a password of 1100. So when 1100, it will give an output of Y equal to 1 at S4. So as we can see here, S4, output of Y is given, and it will next state equal to S5. This is for the next function of the 3-time clock high after the initial state. Okay, for the next case, this case is used for give an additional 2 clock high after the initial is high. So when the S4 is high, it will go to the next state, which is S5. So S5 it will release a Y output of 1, which is high, and it will straight go to the next state, which is S6, and it also give Y equal to 1, and then it will return to the S0. So from S4 to S6, we can see that it will give 3 clock high for the output. Okay, for the last system here, it is to show our clock. So this is always at positive edge clock begin. When reset is equal to 1, the current state will stay at S0, which means the clock is off. Else, when the clock is set to 0, the current state will go to the next state, which is S1. So it's act as a non-blocking statement. Then we end the module.
Assalamualaikum dan selamat sejahtera. My name is Ahmad Lutfi bin Nosham and I will be explaining on question 2 test bench. On the first one, on the line 27, we will start with the module question 2 test, and then from line 30 to line 32, we will set in the input, which is X, clock and reset. Meanwhile, on the line 35, we set the output, which is wire Y. For line 45, for the initial clock begin, we will set clock starts from 0. And then from line 48, forever begin, we will start with clock 5 milliseconds. And then we will start to have the clock on 5 milliseconds for each clock. On line 56, the initial begin post edge clock, which is on the positive edge, we set X for the input for the global 0, then reset equals to 1. On line 62, we put the clock reset after 10 seconds, reset equals to 0, and then input start after 10 seconds again on line 64. Here we have our password on line 66 to line 74. On line 67 is the first digit of our password, which is 0, 69, 0, 71, 0 and 73, 0. So our password will become 0000. So on line 76, which is our correct password, is 1100. So when we run for the first 4-digit number, which is 0000, we start at the clock on the first one, which is on the 20 nanosecond on the positive edge, 0000. And then for the next one, we put our input for 1100, which is start on the 60 millisecond. We get the X input 1, 1, and then 0, 0. So then the password is correct. So the Y input will trigger high for 3 cycles. As previously presented, here is the full flowchart for the whole program. So on the first start, we got the first case S0, Y input goes to 0, and the default next case is S0. So when the first digit of the password is input, if it's the same as X equals 1, if it's true, then it will proceed to S1. If it's false, then it will revert back to S0. So if the second input of the digit is equals to X equals to 1, if it's true, then it will proceed to S2. If it false, then it will proceed and revert back to S0. Then the third input of the digit, the third input of the password, if X equals to 0 is true, then it will proceed to S3. And lastly, if the fourth digit of the password, if X equals to 0, if it's true, it will proceed to S4. Here, the S4 to S6 is the positive 3 cycles that is needed for the output Y equals to 1. So S4, Y equals to 1, then proceed to S5, Y equals to 1, then proceed to S6, Y equals to 1. And on the last one, S6, it will revert back to S0. Thank you very much. That's all from me.